Hey folks, problem number 2. We are just going to do this using the calculator, but we will have to use our t-table to get the critical values. Hopefully you watched the previous example and it made sense. So problem number 2, the null and alternative. Remember our book puts H1. I often like putting HA, same thing. Okay, so this section is all about means, so not proportions, but means. So mu needs to equal something, and then mu either greater than or less than or different. So we need to read the problem. Nature magazine says the average length of a kelp bass is 12.25 inches. You think it's less. Okay, so they're claiming 12.25 inches. We think it's less than 12.25. Notice that these numbers always have to be the same, just like in section 10.2 when we're dealing with proportions. Those numbers are always the same. Those symbols are the same. That's an equal sign. This is either a less than, a greater than, or different. Okay. Critical values. Let's skip that for a second. We'll come back to it. Test stat. Oh, well, let's just do this the magical way. Let's just throw things into our calculator. Let's see. So keep reading the problem. Simple random sample 30, kelp bass, so n is 30. Get a mean length of 11.76. So based on that sample, the mean was 11.76. So sample mean, x bar, 11.76. Sample standard deviation, that's S, 0.945. Significance level, 5%. Okay, so if we just plug everything in, remember it's the t-test, right? So on, clear, stat, tests. Can we see this okay? Slide down to t-test, enter. Okay, so the mean in the null, what's in our null? Oh wait, data or stats? It's not raw data, it's summary statistics, so stats sounds good. The mu naught, the mu in the h naught is 12.25, enter. The x bar, the problem said it was 11.76, 11.76, enter. S sub x, the standard deviation S, straight up given, 0.945, 0.945. Enter, sample size n, 30. Common mistake, you're thinking ahead, you put the degrees of freedom, which is one less, but don't worry about that, just put the n, 30. And then they say, which symbol goes there? We said a less than symbol. So choose the less than symbol, hit enter on it. Slide down to calculate, hit enter, and it does everything for us. So we get a nice test stat of, make sure you write t equal. Don't just put the number. T is equal to negative 2.84. Negative 2.84. Okay. And then, let's see. Our p-value is 0.004, I'll round it 1, 0.0041. And then we said that the alpha level, I believe, was 5%. Yes. Okay, so if I have an alpha of 0.05, how does that compare? 0041, yeah, that's less than 1%. That's less than 0.05. So my p-val is less than my alpha. So I would reject my HO. Remember, we did this on test number 2. And so my conclusion in English, so if you reject HO, then you say evidence suggests. Evidence suggests. And then we just have to say this, that the mean is less than 12.25. Evidence suggests. The mean what? The mean length of what? Of, was it kelp bass? Who writes these problems? The mean of kelp bass in California, mean length of kelp bass in California is less than 12.25 inches. So we're basically done. Remember, the book keeps asking us for critical values in case we do it the traditional way, the classical approach. Okay, so let's do that. Oh yeah, so I was pointing out last time when we went over problem number 1 to let's pay attention what's going on here. So the critical values. So notice that our alternative, let's see, our HA is pointing to the left. Our alpha is 0.05. So if we draw a picture, we're trying to figure out the critical value that goes right here. So if you go to your t-table, I'm going to insert a picture. So if you go to your t-table, and then we need our degrees of freedom also, right? Degrees of freedom is 1 less. So degrees of freedom, n was 30, so df 29. Okay, so go to df 29. And then we want to put 05 on the left. So I see the number 1.699, but you see how it's on the left? My t-table is right tail. So if it's a left tail problem, then the critical value would just be negative. So negative 1.699. So that's 5% in one tail with df29, but it's on the left, so we make it negative. So my critical value, so maybe sometimes it's called t critical, is just negative 1.699. Okay. Now let's see if it agrees with our statistical conclusion. Remember, this shaded region is called our rejection region. And we are trying to figure out where this test stat would land. Remember, the center is 0. So where does negative 2.84 land? So 0, think of the number line. Negative 2.84 probably lands like right there. Definitely inside the rejection region. Therefore we reject HO. Okay, so there's 2 ways to do it. There's 2 ways to get to the statistical conclusion. Hopefully that made sense.